Hello, good morning everyone. I am going to talk about conversion of given finite automata to regular expressions. In earlier classes, we have seen how to get an equivalent DFA for a given non-deterministic finite automata. Now, vice versa is not possible, but given a deterministic finite automata, we can get an equivalent regular expression. Okay, fine. So now, by default, finite automata means we say it's DFA only. There are two ways that we can get a regular expression from a given deterministic finite automata. Okay, so what are the two ways here is, one is Arden's method and other one is state elimination method. Now in this video lecture we talk about how to get a regular expression for a given DFA using Arden's method. Okay, now what is this Arden's theorem talks about is, Arden's theorem talks about Okay, so what is this Arden's theorem talking about is, Arden's theorem is the one who has given this methodology to get a regular expression for a given DFA. Okay, so what is this method talks about is, if there are two regular expressions, let's say P and Q, and P is not having any epsilon, then whenever we have an equation R equal to Q plus RP, then we can replace that equation R equal to Q plus RP by a solution called R equal to QP star. So we have to form an equation in the terms of R equal to Q plus RP. Then whenever we are writing in the terms of R equal to Q plus RP, we can replace that R equal to Q plus RP by R equal to QP star. That is the Arden's theorem statement. Now what are the steps here is, first thing is we have to form equation. How we are going to, how many states have given for the DFA? For each and every state you have to write equation. How do you write equation is, what are all the incoming paths towards each state, we write a equation. Okay, and you have to add epsilon for initial state. Now we are going to get a regular expression for a final state. Solve for final state, and the final state should contain only input symbols excluding states. So the equation should contain only input symbols excluding states. Okay, now this is the step 1. First we are going to write equation for each state including epsilon for only initial state, and we have to solve it to a final state. Final state equation should contain only input symbols excluding states. Okay, you have to solve it. So we are going to write in terms of R equal to Q plus RP, and we say that using Arden's theorem we have a solution, and we replace R equal to Q plus RP by R equal to QP star. Okay, now let us see, we have a regular expression given like this. So how we are going to get it here is, first thing is we write incoming paths for each state. So how we are going to write incoming paths is, we write it like this: A equal to incoming paths from B towards A is from B. Now we are getting incoming path from B on input 1. As A is the initial state, we are adding plus epsilon. We can also write it in this way: A equal to, first write input symbol on input 1 from state B, we are getting incoming path. Or we can also start it like this: A equal to, first write epsilon plus B1. Anyway we can write it. Okay, now the incoming path for B also we write it here: B equal to, okay, incoming path towards B from state A on input 0. Okay, we number it here. This is equation 1, A's equation as 1 and B equation as 2. Now using mathematical, how you going to solve equation? The same way we substitute A equation in B and then we solve it. Now we write it here: substituting equation 1 in, as we have to solve for final state, in 2. Okay, obviously what we have to do is, we have to bring in the form of R equal to Q plus RP, and then we have to do it. Now B equal to 0A. Okay, So what can I write it in place of A? In place of A, we can write it B1 plus epsilon. Based on distributive law, we write it B equal to 0 1 B plus 0 into epsilon. Okay, so what we get it here is B equal to 0 1 B plus 0 into epsilon. Now what we are going to get it here is B equal to 0 into epsilon is anything into epsilon is we will get that only. So 0 into epsilon is we get it 0 plus B 0 1. Now we are writing in the form of R equal to Q plus RP form. So B's are here, 0 is Q and B is R and rest of the thing is P. Now based on Arden's theorem, what we are going to write it here is if equation is in the form of R equal to Q plus RP, we have a solution R equal to QP star. Now we transform this equation. B equal to, what is Q here? 0. P is what? 0 1. Okay. So this is the final required RE for a given deterministic finite automata. This is a regular expression for a given DFA.